Just to follow Alexis said, welcome everybody to come to today's workshop. And hopefully by end of today, we have some sort of common idea or understand what DataCube is about and where DataCube currently is moving, and say eventually how DataCube can be used. And just a bit of administrative, and just in real event, say if the sound of the evacuation, then we have to follow the procedure. And that's we said, okay, by the protocol, we have to tell everybody. And if in the worst case of evacuation, if the sound is alarm, we have to go outside the door and go to the grass area there. And the toilet just goes through the foyer and on the other end of that one, and you should be able to find it. Okay, talking to DataCube, everybody seems to have a different idea of what a DataCube means. I talked to quite a few groups or different organizations, and it seems different whatever concept in their mind, what a DataCube means about. So for today, so we should have, regardless you agree or not, we should have some context we talk about. So at least today, and by end of today, if people have a much better idea how to define DataCube, would welcome. And to introduce the core team, what we are doing, so I try to give a very brief, so what a DataCube, the work currently involved. Because people are all talking about DataCube, so I try to draw a cube. And in this area, we know we start from bottom. Usually we're collecting like Lancet data, Modis data, NOAA data, Spot data, ESTA, whatever the data. So all these data collected need to be processed to a certain level. And we're talking the level is a generic term, okay? Level 1, people have a different idea what level 1 mean about. But some we say, okay, some data at least also rectify the imagery. And we're possible that's a start with. So in our core team on this table, and like Langwei is leading to get the data processed to a certain level, and then make sure all the data is geometrically collected, of course, radiometric collected as well. And we process further, may try to convert from the original D9, whatever the data DN value, and to surface reflectance. So that is one of data we just call data processing. I do not put this one as part of core DataCube because data processing requires some specific knowledge and or sensor knowledge, and usually requires some sort of ancillary information from satellite provider. So GA in this space possible for quite many years, and we're doing this as our day-to-day business, I would say 30 years already. Now, up to this, I put in this part of DataCube. How we give a name, I don't know. I just temporarily name it for data collection. That's where we include the different type of data set. At least at this stage, we know Lancet data, Modis data, and you can have other data as well. Up to this level, if we want to access the data more effectively, we have to think how to organize the data. At this stage, we have Alex Yip, lead as our stream 2. He's the team lead, basically to define how we better organize or manage this data and for easy access. Or access more effectively. And that's where involved how we slice the data in a better way. For example, theoretically, if we manage the data in pixel or measurement level, that is the most effective way to access the data. It's just like Oracle or database query, give me the data at that particular point, at that particular time, or whatever acquired. But you think the data volume there's no database or no way you manage data in pixel level. So we have to compromise, okay, what solution we should provide to manage this data. And now there's a concept, we call it as tile, or some people say it as cell, but tile possible most acceptable. Now what's the tile size? Different sensor, in theory, should have different definition need, depend on the resolution or others. For Landsat, in the prototype, up to now, we arbitrarily use 1 degree by 1 degree as a tile. Is that the most effective way or not? I don't know. It to be evaluated what is the best size for this. Because we're considering time series analysis, say, over 30 years. And 1 degree by 1 degree, 30 years is still too big for memory to take. So we may consider reduce the size. So this is, at this level, we will need to work out how to manage the data collection, and also given different satellite has different resolution, and how we align all these pixels, whatever, in the way you can have meaningful analysis and apply analysis easily. So all this work is a part of our Stream 2 core business of the data cube and Stream 2 work. When this is done, and the next logically from application perspective, of course you need to query the data. And you may develop, because different organizations have different data, different sensors you may manage in different way. As we said, tile size may be different, data structure format might be different, but you need to provide at least a query interface. So people can access the data according to whatever the low-level knowledge, and you can access data easily. So the query method can be query method 1, 2, 3, 4, whatever. You can develop a lot, put it there. But we do need to have a common interface. And that's people easily, regardless of how data is organized, go through the query method you provided. The method includes, say, for example, spatially, you tell me what polygon area I'm interested in, what temporal range I'm interested in, may include the spectrum range, whatever information, and also give me all this information, what you have. And this, actually, I put together, still part of Stream 2. Now, all this, say, assume is done. This is a very lower level. Then people will start, okay, how can I apply some specific methodology to our applications? But the data may be still too big. You want to filter data in different way. Maybe based on the data attributes, say if the cloud covered or not, or some special knowledge we have. So at this layer, we need to define some sort of a filter here. You can have different filter defined. As the filter 1, 2, 3, 4, you can in whatever, how many. As long as I have a common interface, then you apply this filter to the data you create out, reduce the amount of data you are trying to work on. Then you need to apply method. I think lots of people here actually developing quite different type of method. Some common, like NDVI, easy, everybody knows what the method is about. But to detect the water, I believe there's quite a few, at least I know of, 3 whatever seems or published water detective method there. And you may have more method developed. So this is really the application people is interested in. And lots of people want to publish something, most at this level. And I would say this, we need able to provide basically some sort of generic API platform or common method in, I would say, wrap-up or interface, but allow people to develop whatever method you want to. And then on top of that, basically, okay, how apply this method over all the data I originally filled out, may cross the continental, may global, may just a state, or maybe just a local. And you run on different environment. For example, like NCI is the HPC environment, and some is a cloud environment, and some is PC environment. You may require different type of workflow engine and to drive all this and cross all this data. So at this level, we basically, okay, workflow control. different platform or different method also depend on different language or what kind of application or this level available. For example, GA, at the moment we think about Louis, I'm not sure how many people heard about Louis, and we expanded Louis, have called HPC environment, whatever, put in. So you don't have to worry about how I can program at HPC environment. You just use this, apply whatever the method, and only few lines of code, and make sure all you developed can run through with the data you do. And thus you have multiple workflow as well. You can develop on top of that. If we make all this, everybody is called exchangeable, interchangeable, whatever, just like a plug in, plug out, or take out, then most people from application perspective, you just say, tell me, okay, my application needs this data, need plus this data, go through whatever the filter I need to go, may go through more filters, and then apply method 1 or 2 or 3, or use this workflow control and get my result out. And the result can go back to whatever the level, depend, not this level. You can go back, okay, this result is very useful. I want to make another collection of this. Or says, okay, I don't need to go this one, just go add additional information, query out, and go through more filter, and just have a second run annotation. Make it flexible, like a Lego type of approach. So you think all each individual just a Lego item, and you can put it together and to make some sort of whatever. You can make a house, you can make a car or whatever. Of course, this is a toy car. And that's my way think about how we think about data cube is about. So data cube is include everything in this. The core team at the moment developed the focus is the generic interface. We will give some prototype or method as example to make sure itself is proof it's working. But we will encourage everybody to develop more on filter, more on method, or even more on workflow. So at this stage, Simon Oldfield, he is leading overall development of the delivery of data as well as the API. So that's a common interface. At the moment, Simon Oldfield and the lead that stream. And Alex Eve is the lead stream at this level. And then we most work together, make sure the data processed meets the specification of this level. Okay, that's the general introduction. Any questions?
Thank you. I forgot to mention.
I have one question. The API would be the framework to do all that?
Yeah. Talking to API, of course, people will think definitely we need API for that. And that's possible you are interested in. And we do need API for that. And do need API for that as well. But overall, the API, if you put a general term, use this as API, basically how we utilize the data, access the data.
When we said the API, we mean those three things.
Yes.
A lot of the applications for Taylor and Cyro involve creating web front ends.
Yeah.
And you guys put web services.
Yeah.
Being along that diagram we've got there. Would you like to comment on the web services work?
Yeah. The web services depends which level of web service. Two web services. One is I need to get data. From this diagram perspective, basically you have a service here and take the data from this level, go through, for example, web services. And basically this will deliver the data. You still go through these two layers, fill the data, only get the data I required. But further, we're talking about the WPS. I'm not sure how many people are familiar with the WPS, basically web processing service. That means I provide some sort of method, apply the data you have. So if that is the case, WPS is on top of that. You tell me what kind of method I want to apply, go through what type of work engine, and we'll get the result from there. And the result can feed back. And that is the web service. I didn't put this in this one because web services is the interface to whatever the application or others. If by itself, just like a native API, you run at NCI, you don't have to go this type of service to apply this. But if you are not at NCI, you do need web and access all this.
Thanks for that. So can you comment on the APIs?
Yeah.
Where do you have them in place, or what sort of timeline? I mean, is this something you expect others?
I will ask some Oldfield on the day to have a more detailed presentation. So overall, at the moment, I say we're still in development, even design stage. Design plus prototype. And we're aiming by end of this financial year, have some sort of agreed interface there. At least some example is already there, and people can develop more from top of that. On top of that. Yeah. Yeah, thank you.